All right, so this is cross multiplying. When you do this, you do not cross multiply on this kind. You just multiply across. I know that's confusing, but you got to keep it straight. It's only on the kind where they say equals where you would actually cross multiply. Unless you want to find out if they're equal or not. That's another time you cross multiply. It's all about equality. This kind, we just go 3 times 1 is 3, 4 times 2 is 8, the answer is 3/8. Those are very easy. Don't confuse those with cross multiplying. Here, 3 times 12 is 36, 4 times x is 4x, and then you can divide by 4, x must equal 9. You get the difference there? All right. We are going to not do the athlete thing. I don't think we need to do that. If you want to, at the very end, I can go back, and for those of you that are sports nuts, you can see if you can name them. But anyway, let's do this. It's cross multiplying again. Do you know which one cross multiplying? The one with the equal sign. And if you're having trouble multiplying 14 times 3 in your head, do 3 times the 10. Think of that as a 10. And 3 times the 4, and you add them. And then you'll be able to do 3 times 14 in your head. That equals 2x. Then you divide by 2. Here's another way to say it. 3 times 14 is equal to 2x. Notice I didn't even multiply out the 3 times 14. Why? Because now when I divide by 2, I can do some canceling. See, the 7 and the 14 and the 2 have a 2 in common, and I'll never even have to multiply 3 times 14. Because now I can say this 14 is really 7 times 2, and the 2's cancel. That leaves me with a 7 times the 3, and I have 21. Raise your hand if you had that one right. Good, that's most of you. On to the other part, a little canceling first. I know you could go 8 times 3 is 24, and then 4 times 12 is 48. But it'd be smarter if you could notice that this 12 could be written as what times what? What would make it cancel with something? If we wrote the 12 as a what? A 4 times a... Come on, 12 is 4 times what? 3, thank you. Now I can do some canceling, because that 3 will cancel the 3. Now, how about the 8? Can the 8 be rewritten in a logical way? What? Rewrite the 8 as a what? 4 times a 2. And that way the 4's can cancel. I could have canceled either 4. What I can't do is cancel 2 on the bottom, 1 on the top. That does not work. Final answer, 2 left on top over 4 left on the bottom. 2/4. So close, but not right. Final answer, 1/2. All right, good. So this is the same thing. I don't think we need more practice on that. But do you get only one of these you actually cross multiply? The one on the left. All right, moving on. This is kind of like that. It's kind of like cross multiplying, but it doesn't say anything between them. If you want to know if they're equal, you cross multiply them, because we know that times that should equal that times that. It doesn't. 7 times 4 is 28. 3 times 11 is 33. But if you put them down in that order, where this is the first one you would do, logically, because you always would start there, because in the United States, we read from left to right and top to bottom, so the 4 is clearly first. Then, if you put them in order, obviously, you could argue that, but if I'm writing down 2 numbers, shouldn't the one I started with here go on the left side? Because you write from left to right also. So if you put that here, the reason that all matters so much is because now if this is less than this, then that means the fraction is less than the other fraction. All right, let's go to the next one and see if you caught that. Try to tell me if these two are equal or not, or if they're not equal, which one's less? Is it 5/7 is less than 10/11, or is it 5/7 is greater than 10/11? You might think so. First couple answers I've seen, they're not the same. All right. So 55 should have been first. 70 should have been second. That's a less than sign, so it should be a less than. Raise your hand if you had less than. That's most everybody. Okay, moving on. This, cross multiply them. This is a less than, greater than, or equal to. Turn it my way, I'll tell you if you're right. Correct, sir. Yep, 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 yep. yep, 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 yep. Everybody's getting it right. When you cross multiply this, it's just 1,000 and 1,000, and they're equal to each other. Okay. So, this one, can or can't you cancel that x? You cannot cancel it. What part makes it so you can't? The plus. You cannot cancel over addition like that. Now, you can cancel if you can factor the top or the bottom. And once it's factored, and they're in factored form, like a multiply problem, then you can do it. Now, this one happens to add. X plus x is 2x. And then, over x. And then that makes it really obvious. There's only one x on the top and on the bottom, and they cancel, and the answer's 2. But what I'm trying to get at is, if you can factor the top, that's a better way to say it, because you can't always add the things that are on the top, but they sometimes still have something in common. So if you could factor it, do you get how they both have an x? So I can factor the x out, and I have 1 plus 1. I know that's the same as 2x. But if you factored the top and you factor the bottom, it's a multiply problem now. Now I can cancel it. And the answer is 1 plus 1, which is 2. See, that still works when I have this. 2x plus 12 over 2. Can or can't I cancel? The question you should ask yourself is, can I factor the top or bottom? Can factor it? You should. Once you factor it, you end up with this. And now, how come I can cancel it now? Because it's a multiply problem. It's been factored. See, that's a factor, and that's a factor, and that's a multiply problem. That means I can cancel it now. So look for yourself whether or not the thing can factor. And if it can factor, you should. So try that on this problem. Pause for a moment while you answer it if you can. This time I'd like you to turn to a random person near you and check with them. Pause while you try it. Okay, so we're doing least common denominator and having the kids try the middle one and the last one here. We're looking to factor this into 2 parts. This part, I'm not telling you which part, but it shouldn't be too hard to figure out which has been factored and which one hasn't. And then try to figure out what the common denominator should be for both of those. Compare with the kid sitting next to you. I'll pause while you try it. Okay, here we go. So, on this first one, we would have said it factors into 3x and 3x and plus 1 and minus 1. Do you remember that pattern? It's called a factoring a difference of 2 squares. Okay, difference meaning minus. And that's a perfect square because it's got a perfect square root. And that's a perfect square because it's got a perfect square root. All right, anyway, and then you have an x here and a 3x plus 1 there. That's the same as that. So I don't need 2 of them, I need 1 of them though. And I need a 3x minus 1. And then I need one of those, an x. I do not need that last parenthesis. Okay. There is my common denominator. Raise your hand if you had that same thing. Okay, good. On the last one, you can factor this one to x plus, what is it, 2? And x minus 5? Okay, and then I got one of these, so I need x minus 5. And then one of those, x plus 2. And then I need an x. X, which you could argue needs parentheses or not. Either way, it doesn't really matter. Okay, there's my common denominator for that one. Raise your hand if you had that one right. Okay, good. Now let's move on to the worksheet. I'm going to pause for a second while I pull that up. Okay, here's the worksheet. And the first one is laughably easy. The only thing is, it does point out, do you always want to just multiply the 2 denominators together? No, because you aren't then using the least common denominator. It'll actually work. You guys doing the right thing? You're on the right screen? Please be there with me. All right. This could be changed, though, from the 12 into a 3 times 4. And that'll help you see, oh, there's 2 3s, so I only need one of them. So 3 times 4, 1 3 and 1 4, would be a good denominator. Well, that's 12. And we already have a 12. So obviously, no sense in multiplying that by anything. So if I'm going to have a 12 for denominator here, this has to get times by 4, and that has to get times by 4. And then I'll end up with 8 twelfths and 5 twelfths, which makes 13 over 12. And it's best to just leave it as 13 twelfths. Why? Because if you make it a mixed number, you're just making it harder to work with in an equation. So we like improper fractions. Moving on to the next one. On that one, even though you can break up a 6 into a 2 times 3, you're still going to need one of each, which means your denominator needs to be 2 times 3 times 7, which is 6 times 7, which is 42. Probably the denominator you'd have picked in the first place. But this method's still working for us. So if I want the total to be 42, I got to times this by 7 and 7, and this by 6 and 6. And I'm multiplying by 1 effectively then, and that means it's legal, it's okay to do that. From there, that one should be easy for you. Here, number 4 is the first example of a kind where our system kind of messes up. Would you agree this 2x squared could be written as a 2 times x times x? And the 3x could be written as a 3 times x. And our system would say, use one of each, 2 and a 3 and an x. That means the ideal denominator would be 6x. But this has already got an x squared in it. How can you make the denominator be 6x if the thing's already a 2x squared? So if you remember back to that slide, if something already has 2 of something, like x squared like that, you have to include 2 of them in your denominator. I need another x, because this has x squared in it, and I can't make it get smaller. So now that I've figured out my denominator is going to be 2, 3x, and another x, that's 6x squared. Now I can multiply this by 3 on top and bottom, and it'll all work out fine. And how do I get this to turn, the other side here, 3x, to turn into a 6x squared? I multiply by 2, that makes it 6x. 2x makes it 6x squared. Yay. And then I have to do it on the top also. All right, so that's the one where the denominator wouldn't have been possible for us to use a 6x for a denominator, because this already had a squared in it. So that's the tricky exception kind. All right, let's move on to the next one. Would you agree that the 3 elements are a 7 and a 4 and an x? You need one of each. An x. Therefore, 28x is a good common denominator. There you just got to be careful with negatives. So this one needs a 7. Remember, there's a negative on the 5. That negative is not on both the 5 and the 4, otherwise it would have canceled out and it'd be a positive right now. That negative is only on the 5. This negative right here, that's only on the 2. It's not on the 7x. Now granted, you could put it on the 7x and not the 2 if you want to make it more confusing, but we just generally put the negatives on the top. Okay, then if my denominator's got to be 28x, this one has to be times 4 and times 4. And that's legal because I'm multiplying by 1 on both sides. Then I'll have a common denominator. Then you just be careful with your negatives. Negatives. There's an extra negative on that. And this one, it's a negative 2. Better way to think of it. Okay. I think you got the idea here. And the rest of the time is work time on this worksheet. One more thing to announce. For this year's test, we feel like the test is actually a little bit on the hardish side. Not impossible, but there's some challenging questions, and it's kind of short. And that's always tough. If you only have 8 questions, you know, and you get 2 wrong, sounds like, well, I only got 2 wrong, but it's like a B-. So what we're going to do is count it only as homework. So this test does not count in the summative 85%. It counts in the formative 15%. Okay, so if it doesn't go so well for you, it's not going to hurt your grade too bad. Okay? All right. That also means, because this is some tough stuff you're learning right before the final, we're not going to put this stuff on the final either. That'll make your life a little bit better. All right. Now, there's still reason for you to try, because it does count in the 15%. And that category does make a difference. You could use a decent grade in there on Thursday when we take this test. But if you're going to stress about something, don't stress about this. Stress about the actual final, which comes in about a week and a couple days, and that one does count a fair amount, 15% of your overall grade, all at once. Same weight as homework has had all year, or which is an interesting concept to have one test count. the same, or at least all semesters. All right, most people, unless they just have been barely hanging on the whole time and kind of faking it through, if you've been getting solid A's and B's the whole time, you probably get a solid A or B on the final. You probably get about the same grade you usually get, minus about a half a grade. From my experience, most kids don't do better than usual. They do it like a half a grade lower than usual. Just because it's the final and you got so many other things to study for at the same time, and you got to know like 25 topics, so it's hard to get as good as you normally do. But for most people, it does not drop your overall grade. For most people, it keeps your grade about the same as it was. Now, only if you're one of those kids where you're hanging right on the edge, and say you've got a B minus minus, and you almost are in the C's. Well, of course, then your final will make a difference. Okay, so if I were you, I'd be looking at your grade at this point, saying, do I have a cushion of like 2, 3, 4%? In which case, then the final, it really is be difficult for it to hurt me. Okay, unless you bomb it, which means study for it either way. It's just whether or not to like do the uber study level probably depends on how close you are to a borderline. Sir, is there going to be a curve? Nope, the final doesn't get curved. It's a good question. Other schools do it all the time, and frankly, in Minnetonka, we used to. We used to take the final and then say whatever the top score is, that's 100%. And the reality is usually nowadays there's somebody who hits 100% anyways. Now you also would sometimes throw out that very top score if they're separate from everybody else. Like let's say there's 250 kids took it, only one of them got a perfect paper, and the next closest score was like 5 wrong. Well then a lot of times we'd scale the test down and take off 5 points off. It's not legal anymore. Like Minnetonka's grading policy does not allow us to do that. Basically, what it does allow is if there's a certain kind of question that everybody gets wrong, you can say, well, then that probably wasn't a fair question. If like 2/3 of the kids are getting that one wrong, then we'll throw that one out. We can throw out a question, but we can't like rescale the test size. So it won't be a curve, but if there's any unfair questions, we'll get rid of them. Yes. Good question. In this imaginary world where there is a curve, and the question was if everybody collaborated to fail the test, would that mean that everybody would get an A? Actually, what that means is that the curve is supposed to center the average score around us. So therefore, theoretically, in the theoretical world, the average score could be a 0, and then that could be given a C. Again, it doesn't usually work that way, but I got you. I get how you could game the system. We really don't have much of a system to game unless you were somehow able to convince every kid to not know how to do whatever one topic on the test. And I know I'm recording, and these are questions that come up in class. So that would be pretty difficult. Any other last questions? Okay, and that's all I got for the review for today. And this is not the last review of the final. This is the review of day 2 of rational expressions. Tomorrow we'll do day 3, and then we'll review a little bit, and then the test will be the next day on rational expressions. But it's only going in the 15%.